Anaplerotic reactions. The citric acid cycle intermediates are used in biosynthetic pathways as well. It means to synthesize some molecules, you use the intermediates of citric acid cycle. Now, this anabolic nature of Krebs cycle has raised a question. That is, how the level of intermediates can be replenished when certain intermediates are removed for anabolic purpose. Now, Kornberg have proposed the term anaplerotic for this replenishing and filling up reactions. Now, in animals, the most important anaplerotic reaction is catalyzed by this enzyme known as pyruvate carboxylase, which is a mitochondrial enzyme, and it catalyzes the conversion of pyruvate into oxaloacetic acid. So pyruvate is converted into oxaloacetic acid, and this conversion is catalyzed by a mitochondrial enzyme which is known as pyruvate carboxylase. And this conversion of pyruvate into oxaloacetic acid is the most important anaplerotic reaction that is occurring in animals. So this is how it looks. Pyruvate is getting converted into oxaloacetate, and the reaction is catalyzed by pyruvate carboxylase, and in this process a carbon dioxide molecule and ATP is utilized. Now, in plants and bacteria, there is an alternative route by which the phosphoenol pyruvate is converted into oxaloacetate. In animals, the phosphoenol pyruvate is converted to pyruvate, then that pyruvate is converted into oxaloacetate. But in case of plants and bacteria, there is direct conversion of this phosphoenol pyruvate into the oxaloacetate. They have an alternative route for that. So this is how it looks. Phosphoenol pyruvate is getting converted into oxaloacetate in the presence of PEP carboxylase, and HCO3- is utilized. So this reaction is taking place in case of plants and bacteria, and in case of animals this reaction is taking place. That is, pyruvate is getting converted into oxaloacetate. There is a related enzyme known as phosphoenol pyruvate carboxykinase. This enzyme also converts phosphoenol pyruvate into oxaloacetate. So PEP carboxylase and phosphoenol pyruvate this PEP carboxylase and PEP carboxykinase, both of these enzymes are able to convert the phosphoenol pyruvate into the oxaloacetate. Now, in addition to pyruvate carboxylase and PEP carboxylase, there is a third anaplerotic process which is provided by this enzyme commonly known as Malate enzyme, and its official name is Malate Dehydrogenase. So Malate Dehydrogenase is also providing you a anaplerotic process. So this is how that reaction looks like. Pyruvate is converted into malate in the presence of Malate enzyme, and in this process bicarbonate and NADPH are being utilized.